Welcome back. Today, we're diving into something that's quietly but absolutely radically reshaping the very fabric of our reality. We are talking about the Internet of Things, or IoT, and cyber-physical systems. If you've ever wondered how the physical, digital, and biological worlds are merging together to create these incredibly intelligent assets, well, you are definitely in the right place. Let's get into it. Look around you right now. Just take a second. Look at your desk, your coffee mug, maybe the walls of your room. Pretty normal, right? Now, ask yourself, what happens when that physical world actually wakes up? What happens when those inanimate, everyday objects suddenly get the ability to sense their environment, process that information, and then communicate it back to us? It honestly challenges our entire perception of the physical space we inhabit. Dr. Samon Sarbesvatan's research captures this transformation perfectly. To quote the source, these technologies empower intelligent assets and help us connect the physical, digital, and biological realms. And by doing this, they create these amazing dynamic feedback loops. It's not just about hoarding data anymore. It's literally about breathing life into the physical world so it can actively participate in making our systems more efficient and a whole lot more sustainable. So here's our roadmap for this explainer. First, bridging physical and digital. Second, decoding IoT and CPS. Third, empowering intelligent assets. Fourth, smart industries in action. And finally, driving the circular economy. All right, starting with number 1, bridging physical and digital and the anatomy of intelligent machines. To really wrap our heads around these complex systems, it kind of helps to think of them like a living, breathing organism. At the most basic, foundational level, we have the Internet of Things, IoT. You can think of IoT devices as the senses of our machine. These are the eyes, the ears, the skin. They're sensors placed out in the real world, constantly monitoring the environment of different assets. They feel for temperature changes, they watch for motion, they track location, and they continuously check the physical condition of whatever they're attached to. And the sheer variety of these sensory inputs available to us today is just wild. We aren't just talking about a basic digital thermometer here. We've got sensors measuring acceleration and tilt, detecting the presence of water or humidity, monitoring tiny acoustic vibrations, and even sniffing out chemical or gas leaks. Our machines have basically developed a highly acute, hypersensitive nervous system. Now, we can contrast those sensory IoT devices directly against cyber-physical systems, or CPS. If IoT devices are the senses gathering all that raw data, CPS is the integrated brain and central nervous system. CPS takes those tiny sensors and completely infuses them with massive computational power, heavy processing capabilities, and advanced networking. They link the machines in the physical space directly to digital services, which allows for real-time, totally data-informed decision-making. It's a real game changer. Moving on to part 2, decoding IoT and CPS, and how we scale this whole ecosystem. The crucial point here is that we don't just stop at one isolated smart device. The connectivity scales outward, kind of like a giant bullseye. We start right in the center with people and our wearable tech. Then it expands out to vehicles, further out to our smart homes, even further to entire towns and smart cities, expanding into commerce, and finally reaching these massive global industrial networks. It all scales seamlessly. And when you scale that connectivity all the way up, you start transforming massive macro domains. We're talking supply chains, energy grids, global agriculture, urban manufacturing, and human mobility. All of these are currently being completely revolutionized by intelligent assets acting in absolute harmony. The data flows from the tiniest little sensor all the way up to the massive city grid. Let's ground this in reality with part 3, empowering intelligent assets, featuring the Edge Building. Take Deloitte's The Edge Building in Amsterdam, for example. It is widely hailed as one of the smartest, most connected office buildings on Earth. But it's not just a beautiful glass structure to look at. Because of its deeply integrated cyber-physical systems, this building actually generates more electricity than it consumes. Let that sink in. It is an active, net positive participant in its own environment. And the way it achieves that is brilliant. Behind all those beautiful glass walls is an incredible digital brain. A bustling central dashboard runs the Edge, processing live data from over 28,000 individual sensors scattered throughout the building. 28,000! These sensors are constantly detecting light levels, room temp, humidity, even carbon dioxide levels, and they're automatically adjusting the building's systems to maximize human comfort while utterly minimizing any wasted energy.
Which brings us to part 4, smart industries in action. Let's look at logistics and agriculture.
Because, this tech goes far beyond cozy smart office buildings. It's actively revolutionizing heavy, global industries where efficiency is literally a matter of global survival. Take global logistics. The Danish shipping giant Maersk actually partnered with Ericsson to use this exact technology stack across their incredibly complex supply chain. By utilizing cloud computing, analytics, and IoT, they can actively monitor the safety, efficiency, and cargo care of a staggering 300,000 refrigerated shipping containers in real time. Just imagine having your finger on the continuous pulse of 300,000 individual containers moving across the world's oceans.
Or consider waste management. Over in France, a company called Aloaoil uses smart logistics, completely powered by IoT, to collect used cooking oil from over 25,000 restaurants. They use smart tracking to constantly optimize their collection routes and transform that bio-waste straight into biofuel. And because their logistics are so hyper-efficiently guided by this real-time data, they've achieved an amazing 87% reduction in greenhouse gas emissions. 87%! That's huge!
And, perhaps most critically, agriculture. The Food and Agriculture Organization notes that by 2050, our global population will require us to produce 70% more food. 70%! We have limited arable land and changing climates. This makes precision agriculture IoT solutions, like those developed by John Deere, which monitor soil conditions, automatically adjust irrigation, and track cattle in real time, an absolute non-negotiable necessity for our future survival. Finally, Part 5, driving the circular economy and looking at the big picture.
If you take absolutely nothing else away from this explainer, this is what you should remember. Bridging our physical and digital worlds delivers these 10 tangible world-saving benefits. We get dynamic feedback loops, we get predictive maintenance, literally fixing things before they even break, which slashes downtime. We optimize our resources, we drastically reduce waste and pollution, lower our energy consumption, and finally gain total unprecedented visibility over our global value chains. These aren't just buzzwords, they are the true technological enablers of the circular economy.
So, I want to leave you with this provocative thought. Look around the room one more time. If every single object around you right now could sense, think, and communicate in a concerted effort to eliminate waste and optimize energy, what would our future actually look like? Thank you so much for exploring this fascinating topic with me today. Keep learning, keep questioning, and I will see you in the next explainer.